The next presenter is Professor Vladimir Polyansky from Russia. Please. 15 minutes.
Thank you.
I will give you a sign when
yes.
5 minutes remain.
Yes. Thank you. Thank you very much. Thank you very much, Professor Dutic, for organization of this forum. And I'm honored to see here a famous professor whose work I cite in my paper. And my presentation about new results, and this is maybe not common results that I would like to invite, or I would like to introduce you in this news, because it is not a fake news from Russia. And I present the powerful group of scientists in Russia. Here you can see the Professor Belyaev, it is academician of Austrian Academy of Science. Professor Indeitsev, it is academician of Russian Academy of Science. Professor Konopelka, it is the main meteorologist of Russia in GZ Talons. He works in our meteorological institute. It is my father, it is the head of the production company that produced the equipment. It is our young Professor Yuri Yakovlev. And here you can see the organization in which we make our investigation and development. And this presentation also was supported by Siemens company. And the first step of our research and development was the development of the measurement equipment. We very well know how to measure the hydrogen concentration in solid body. It is our hydrogen analyzer that was developed in approximately from 1995 to 1998. And the first our device worked 20 years in our metallurgical factory. Now we have many customers, and here you can see the quality of our equipment. It is the extraction curve for aluminum alloy. It is the flux of hydrogen per time during heating of the sample. You can see the phone in our background in our equipment. It is the same, and it is the process of unloading of the sample from extraction system. You can see after some oscillation, the hydrogen flux limit to the same phone, and it is the somehow unique investigation. It is the small cut of our customers. Here work 3 our equipment devices. Here work also 3. Here work 3 devices. With this Sandia National Labs, we make 5 research projects, but its interest very specific because the main topic it is the zirconium alloy, not as in another industry. And we have, as the Professor Nzingin say, we have the some topic in our investigation. It is the latent period of hydrogen embrittlement, in which the total concentration, total amount of hydrogen is very small, but its influence increase, and after that lead to the common hydrogen embrittlement and to breaking of meshing part. It is the first. The second, it is the new interest of industry, new most powerful interest from industry to the hydrogen investigation. The first, it is the highest strength material. Here you can see the common gas pipeline tube with cracks. These cracks may have the time period, for example, 8 years, 10 years. And during ultrasonic inspection, the inspector see the see the cracks and its propagation very slow. But here you can see it is the real from Russia, real episode, 200 meters of the tube destructed after 3 days of ultrasonic inspection without any crack. It is the highest strength material, the hydrogen embrittlement in this material. It is the very dangerous but not detected, not common detected phenomena, and it is the very important for all parts of industry, not only in gas, but in, for example, high strength bolts and another application of high strength material. It is another application, the finger. It is the diameter 500 millimeter, broken due to hydrogen embrittlement, also without any initial cracks in this finger, because it would be maybe after 1 year after inspection, ultrasonic inspection of this finger. So now we have hydrogen problem in most important parts of industry, and here you can see some scheme of this problem. But we have another real new problem. Here you can see some cinema about the influence of hydrogen on the properties of industrial parts. It is the real for all industry, not only for Russia, but also in European industry, because it is the sum of the results of recycling of metal. And you know that in Europe there are the frame program, and in 2025 all metal must be recycling in the place of Europe. It's lead in the same effects in European metallurgy, for example. And this is third part of my introduction. It is the real history. 5, no problem. 5 minutes. It is the real history. In 1861, the Free developed research and developed the first hydrogen investigation and its application to metallurgy, and say the steel must be steel only after extraction of the hydrogen from metal. And here you can see the patents. It is the American patents, process of making alloys of iron and hydrogen. And after the Free, maybe 50 years, hydrogen was used as some part of metallurgical process. And only after 60 years, the first work about the initiation of hydrogen embrittlement by this process. And it is our results. We make saturation, standard saturation of hydrogen, by hydrogen of steel, very, very different steel, and after that we make the measurement of distribution of this hydrogen concentration after saturation. Here you can see real non-uniform. It is the micrometers, 100 micrometers, 50 hundred of micrometers, and it is after 150 hours of saturation. The same result was published for electrolyte saturation in electrolyte with some current, and it is the very important because now we have another process in industry. Common saturation of hydrogen that we apply during our investigation don't adequate the real situation in industry. Only one process, it is the galvanic saturation during production thin layer of metals by galvanic methods, maybe the same model of saturation of hydrogen as maybe 90% of our investigation. And it is the problem that we need to solve, and we need in new methods of investigation of hydrogen concentration now. Thank you very much for your attention.
We have some time for questions. Please.
What method do you use to measure the hydrogen?
It is the mass spectrometrical analyzer. We heat the sample in vacuum, in higher vacuum, maybe -7 degrees by millimeter. And after that, we measure by the measure of hydrogen flux by mass spectrometer. Very, very high sensitive. Now we produce, for example, this reference sample with concentration 0.06 ppm. And we can measure the distribution of hydrogen in this level, in metal parts, with our equipment.
One more question, please. We have time.
So just continuation of the question that Bill asked me. So how long does it take to reach to the vacuum? And then can you comment on the hydrogen outgassing during this period of time from your sample until you reach the vacuum?
We have two sorts of hydrogen. We have many sorts, but the main. The first, it is the hydrogen that not bound with the metal. It is in cracks or maybe is in dislocation. This hydrogen extraction in room temperature time, it is approximately 1-2 hours, maybe more quickly, more slow. But this hydrogen, after crack propagation or crack initiation, don't influence on the mechanical property of the metal. We must understand that if hydrogen don't have bond energy with metal, it cannot influence to its mechanical property. Cracks influence, but hydrogen not. And we measure the bond hydrogen with different bond energy. We can determine this bond energy. This hydrogen don't extract in a vacuum, for example, for 1-2 hours, for which we prepare our extraction system and prepare our experience. Thank you.
Professor Polyansky, thank you very much again
Thank
for
you.
a very nice presentation.